So in this video, I'm going to use the binomial expansion of the square root of 1 plus 3x to estimate the square root of 1.03. I'm going to find out how accurate our estimation actually is. So to do this, first of all, I'm going to define a function as our square root term here. So f of x equals square root 1 plus 3x. Now this is equivalent to 1 plus 3x to the power of a half. So anything to the power of half is a square root, and that's our input there. Now for the binomial expansion formula here with a fractional indice or a negative indice, we need to write this in a general form first. So we've got 1 plus ax to the power of n. Now our f of x is of the form 1 plus 3x to the half. Let's just write that here and put our little bits that we need from here. So ax is 3x and our n is a half. So that's our building blocks to start with. Okay, now let's just put this in a box. Now the binomial expansion formula for terms of this format, what our general way to write it is 1 plus ax to the n. That equals 1 plus, then we get n times ax. So we've got n, I'm going to put the ax in a bracket, you'll see why in a moment, and I'm going to divide it by 1 factorial. Now that seems pretty trivial, but there's a pattern in our general formula to work these out. So the next term is n minus 1 times n times ax squared over 2 factorial. So you can see what's happening here now. I've got ax to the power of 1, which was trivial, and 1 factorial, which is just 1. But here you can see now I've got two terms, an ax squared and a 2 factorial. And I've subtracted the n by 1 here. So now the next term, kind of see what the pattern is now, n minus, let's make that a 2, n minus 1 and n. And then I've got ax cubed, so the whole thing cubed. Remember to use the brackets around the ax, and divide that by 3 factorial, and so on. And that can keep going on for as many terms as you wish. For this estimation here, I'm going to use this, this, and this term here. Okay, now we've got our building blocks here. Ax is 3 and n is a half. So all I've got to do now is just by substitution to substitute those into there. So now I've got f of x. Remember, this is an approximation, so I'm going to use my approximation symbol. So I've got 1 plus, so wherever I see an n, I'm going to put a half, and whenever I see an ax, I'm going to put 3x. So I've got 1 half times 3x to the power of 1 divided by 1. Nice and straightforward. And then I've got a half minus 1 times a half and 3x squared, and 2 factorial, that's just 2. And then my next term, I've got a half minus 2, half minus 1 and a half. Ax is 3x, that's cubed, and 3 factorial is 6. So that's where I'm up to now. So all I need to do now is just tidy this up a little bit. So f of x is now approximately 1 plus, I've got 3x to the power of 1, which is just 3x, and a half, so that's just going to be half of 3x. So I've got 3x over 2. Next term here, I've got minus a half times a half, so that's minus a quarter. So let's just go through the steps with this one a little bit more careful. 3x squared gives me 9x squared. So let's just write that like that. And then the next one, I've got minus 3 over 2, minus a half and a half. So if I do minus 3 over 2 times this one, because that and that is here and here. So minus 3 over 2 times that will give me 3 over 8. And then 3x cubed is 27x cubed. And then divide that by 6. Okay, let's go through, tidy that up even more. So I've got 1 plus 3x over 2. Now I've got a minus sign here, so I'm going to not put a plus there, put a minus. And I've got a quarter divided by 2, which is 1 over 8, but times by 9. So that's going to give me 9x squared over 8. Here I'm going to be left with a positive, so I'll put my positive in there straight away. So I'm going to have 3 over 8 divided by 6. It's going to give me 3 over 48, which will give me 1 over 16. And then times by 27. So that's going to give me 27 over 16. And then x cubed. So that's my approximation for this so far in terms of the formula to use up to the x cubed term. So that's where I'm up to so far. But I want to use it to estimate 1.03. So I need to find a value of x to put into this to find my estimation. So I can't just put x is 1.03, that's not going to work. So what I've got is this bit here, 1 plus 3x to the half, and square root of 1.03, I'll set that equal to that because that's what I'm estimating. So now let's just draw a line underneath, and now I need to find our magic x value. So we've got 1 plus 3x equals 1.03. And let's just solve for x. So subtract 1 from both sides. So 3x equals 0.03, subtracting 1. And then x will equal 0.01, divide both sides by 3. Okay, so what we're going to do now is get this x value and plug it into my expansion. So I'm going to make a note of that over here. So use x equals 0.01. Okay, put that in there. So I'm going to clear this off the board and then I'm going to go into the next stage where we find an approximation for this. So I've got my x value to use to approximate this 1.03. And here, using the formula, this is my approximation for up to the x cubed term. So now all I need to do is plug this into this. So let's go with f of 0.01. So that's going to give me 1 plus 3 times 0.01 over 2 minus 9 times 0.01 squared over 8. And then same again with this one. Plus 27 times 0.01 cubed over 16. Okay, now all I do now is put this through my calculator, and this will come to 1.014889188 and a few more digits that you can put in if you wish. So that's what this will estimate this square root term to be. Now, what I want to do is find out how accurate that is. So to find out how accurate that is, I want my percentage error. So my percentage error, that gives me my, or to calculate that out first, I need the estimate minus the actual and divide that all over the actual times by 100. So using the figures I've got with this as my actual value and this is my estimate, I've got 1.014889188 minus square root 1.03, divide that by square root 1.03 and then times that by 100. And then if I do that, put all those numbers through my calculator, I will get 0.0000031%. So that is pretty accurate, I would say, to what, 1, 2, 3, 4, 5 to the 6th decimal place in terms of percentage. So that's going to be really, really accurate. So that will answer all of my questions. So So that's how accurate it is. This is my binomial expansion of 1 plus 3x square root. And then this is my actual estimated value. So there's the 3 component parts towards my answer. And we also want to work out to what values of x is this expansion valid. Now to do that, all we do is use this AX input. So always, let's just put this in the box here because this is what we're going to need. We've got absolute value of AX must always be less than 1. So in this case, we've got 3x. So the absolute value of 3x will be less than 1. So in this case, divide by 3, my absolute value of x must be less than 1/3. And that's what will make this expansion valid. Okay,